Today we're going to be talking about constant and varying rate of change using tables. We're also going to jump into tables and graphs in a little bit. But a constant rate of change means that things are changing at a consistent rate. A varying rate of change means that things aren't changing at the same pace. They're changing differently depending on different times or different input values. So for this first example, we have an example where it says Fiona adds money to her bank account each week shown by the table. Here's our table. Use the table to answer the questions. So for week 5, she has a $145 balance. For week 6, she has a $160 balance. Week 7, $175 balance. And week 8, $190 balance. What is the amount of change between each value in the bottom row, in the balance row? So what's happening from here to here? Well, we're adding 15. From here to here, we're adding 15. From here to here, we're adding 15. So the amount of change is $15 here. So what's the amount of change between each value in the top row for the weeks? Week 5 to 6 is 1 week, 1 week, 1 week. So they're all going up by 1 week. So I'm just going to show that in my table here, that the amount of change here is plus 1 week. And so down here it says, compare the change in Fiona's balance to the change in weeks. Write each comparison as a rate. So the change in dollar amount is $15. Over the change in weeks is 1 week. Remember that when we write things as a rate, we use labels, so make sure that you do have labels. $15 over 1 week. And now it says, does this situation represent a constant or varying rate of change? How do you know? Well, remember that we said constant rate of change means that things are changing the same from one to the next. In this case, we add $15 for 1 week, $15 for 1 week, $15 for 1 week. So this is a constant rate of change. Because our ratio is the same every time. (15/1, 15/1, 15/1). So at this rate, predict what her bank balance will be during week 9. Well, if we were going to add another spot to our table, week 9, we would add $15 to $190, and I would predict then that this would be, her balance would be $205. And I did that by doing 190 plus 15. At this rate, what do you think her bank balance was at week 4? So if we backed up 1 week, we're trying to think, well, what number did we add 15 to get to 45? So 145 minus 15 to kind of back up a week gives us week 4. We would assume she had $130. And how much money did she start with in her account at week 0? Well, if this is truly a constant rate of change, and at week 4 she had $130. That would mean week 3 she had $115. At week 2 she had $100. At week 1 she had $85, and at week 0 she had $70. So I just took my weeks and went down by 1, and then I took my balance and went down 15 each time until I got to 0, which at week 0 we would guess she had $70 in her account. So does this table represent a proportional relationship? Proportional relationship is a review of what we've already done. Remember that proportional relationships are linear, which means they have a k value, they have a constant of proportionality. In this case, we do have a constant, 15/1, 15/1, 15/1. This is a linear equation or a linear function being shown here. However, in order to be proportional, it had to be linear and go through the point 0, 0. Because she started with $70 at week 0, this is not a proportional relationship. No, because, and when we explain, it's because the week 0 mark is at $70, not 0, at the origin. If this was going to be proportional, we would have had to start with $0 at week 0 and then continue to have a constant rate of change. So something that's a common misconception is that anytime you have a constant rate of change, it's proportional, and anytime you have a proportional relationship, you have a constant rate of change. And only one of those statements is true. If you have a proportional relationship, you're going to have a constant rate of change, because constant rate of change and linear go together. And if something's proportional, we know it's linear. However, we cannot say the same that if it's a constant rate of change, it's automatically proportional, because as we see in this example, it can have a constant rate of change but not go through the origin at 0, 0. And so as we talk through, we're going to be talking through a couple more examples today, and we're going to really hit hard constant and varying rate of change and reviewing that idea of proportional relationship or directly proportional.